Hello everyone, I'm Yuriy Zaychik from Luxoft. I work in automotive navigation area, and today I want to tell you about the tools that would be definitely useful for Java GIS developer. So let's take a look on our agenda. At first I will give an introduction about geospatial data, coordinate systems and data formats. Then we will observe tools for processing GIS data, for storing the data and visualizing it. And in the end I will show you a small workshop on how to create a simple GIS web application. So what is geospatial data? It is information that combines object characteristics with its location on Earth or near it. As an object can be considered any physical instance like a building, a tree, a river, or some event like TMC message about traffic jams. An object has a certain set of parameters like size, color, time, and others, and it is bound to location represented by longitude, latitude, and in some systems also altitude. Geospatial data is usually represented in two main forms, either raster images or vector data, like geometry points, lines, polygons, and other. But to properly show and measure the object location, you need a coordinate reference system. Such system is a mathematical toolkit which consists of a mathematical model of Earth, like spheroid, ellipsoid, or other surface, geodetical data. It is a set of reference characteristics for the mathematical model, map projection, and a measure unit. There are numerous reference systems for different purposes. Mostly they are used by industries involved in geodetical activities like gas and oil industries. But the two most famous reference systems are VGS 84. It is a standard for cartography and also used in GPS system. And the second one is Web Mercator. It is used in web mapping applications like Google Maps, OpenStreetMap, and many other. Such system has an EPSG identifier. EPSG stands for European Petroleum Survey Group. It was an association of oil companies in 1985, which gave birth to this kind of standard for describing reference systems. So this identifier stays till now to omit confusions. With the raster images, it's like all clear. There are no many formats for showing GIS data in raster, like GeoTIFF, JPEG 2000, but I think it's a more topic for enterprises that are involved in satellite imagery, but for regular GIS developers, vector data formats are more interesting. There are like two representations of vector data. One is a text representation called well-known text. Here on the slide you can see text representation for a square. Here comes the name of the feature form. Polygon here could be a point, a line string, and many others, and a set of coordinates. And the same can be stored in binary format. The first byte stands for little endian or big endian record type. Then there goes code for feature type, and the rest of bytes store the longitude and latitude. So now let's talk about the libraries for GIS data processing. GeoTools is most famous GIS library in Java. It is an open-sourced library, and it provides methods for manipulating with geospatial data. It uses many standard interfaces like Java Topology Suite, OpenGIS. It implements some core functions like creating geometries, aggregating geometries, like making unions, intersections, and so on. And also it has tools for converting geometry data from one reference system to another. Also it has plugins, for example, for different geospatial data storage formats like shapefiles, relational databases like PostGIS, and so on. Later I will show you some use cases for GeoTools. So what about choosing the storage for geospatial data? There are many options like shapefiles, Oracle, DBMS, PostGIS, an extension for PostgreSQL, MariaDB from creators of MySQL, and many others like KML, GeoJSON, and so on. Let's stop on shapefiles. Shapefile stores non-topological geometry and attributes of an object. A shape package consists of 3 files: SHP, which contains coordinates of an object; DBF, which contains a set of attributes; and SHX, it is an index file. This file comes from early GIS systems, and today also many geospatial data suppliers use this format. shapefiles take its root from DBase format. It was database management system in early 80s, and it can be considered as something similar to SQLite. Another option for storing geospatial data could be relational DBMS. So PostGIS could be a good choice. It is an extension for PostgreSQL database system, and it has such useful features like spatial functions in SQL queries, like you can manipulate with geometry in SQL, dedicated data types, geometry and geography, and also it has spatial indexes for geometries. So now I will show you some use cases of PostGIS. Okay, let's see some examples. As I said, PostGIS is an extension for PostgreSQL DBMS. It also is available as a Docker image. Actually, this server runs in a Docker container. So everything looks like pretty the same as ordinary database, but after creating the database, you will need to add a PostGIS extension to it, like running such query. I have prepared a sample data set with world coastlines. So let's take a look at our data. So here you can see attributes and geometry. This is well-known byte format. As you can see, the first byte is little endian, then everywhere you can see the same code. It stands for multi-line string, and then the set of coordinates. But this is not kind of readable form. So let's see how we can make it more readable with querying. For example, we can run the following query. PostGIS have special function to show the geometry as a text. So let's wait till the query completes. And now finally we can see now the identifier and more readable representation of geometry coordinates. Also, PostGIS has useful functions for manipulating with geometry. For example, we can select a data set that intersects some certain region. So it will look like this. And as a condition, we also use a spatial function. Geometry of our object. Then we will add a point with some buffer. We will need to set coordinate system ID. For example, let's take coordinates 65 and minus 25. We will use GIS. And the buffer of 25 units. Some small mistake. So we can see that only 12 features lies in this buffer of 25 units near this point. Also, PostGIS have spatial indexes for geometries, which deals with geometry bounding box, and it is helpful for performance if you run such queries on large data sets. And now let's talk about the tools for visualizing GIS data. One lightweight tool is an OpenJump. It is open source GIS written in Java, developed by volunteers around the world. And its main features are it can read and write shape files. It also can read from spatial databases like PostGIS. Also, it deals with WMS and WFS formats. I will talk about them a little bit later in our workshop. And also it is extensible with plugins. So now let's take a look on how to use it. So let's, for example, open some shapefile. Let's use the same coastlines as we did in PostGIS. So this is how the world coastlines look. Also, you can change the style of this layer. For example, change the color and width of the line. That's too thick. Also, you can use color theming and to differentiate by some attribute, for example, minimum zoom. You can see now for different features the color is changed. Also, you can add labels to geometries. For example, let's use feature. It's the same for all features, but as an example, good enough. Also, you can write and create your own features like points, line strings, polygons. Also, you can make notes on the map. So this tool is good for when you need to analyze your geospatial data. So that's clear with OpenJump, and let's go to the next tool. Forget about to say that one useful tool is feature information. For example, select some feature and see its attributes and even see its well-known text geometry representation. So okay, let's move to another tool. And the next tool is QGIS. It's also open source GIS system. It's more sophisticated than OpenJump. It also has the same features for viewing, analyzing, editing, importing, exporting GIS data. So let's have a look. QGIS. Let's create a layer from PostGIS data. You need to create a connection. Let's call it pgcon. We'll need connection parameters. Let's test the connection. Oh, I have a mistake here in IP. Oh, the connection is successful. Okay, so here we can observe our schemas, and let's create a layer from our coastlines. Okay, here we can see the same data. Also, we can use information to see the attributes of data, same as an OpenJump. Or we can use styling for layer, and also the useful feature. For example, we can just out of the box add OpenStreetMap layer. So now you can see our coastlines. connected with OSM raster layer. Okay, so let's move next, and our next topic would be how to create a simple web.js application. So let's talk about the technical stack. As a storage, we will use PostGIS database. Then we will need some servlet container like Tomcat, Jetty, or any other to deploy there our web application that will use Spring Boot and GeoTools. Actually, it can be even a standalone Spring Boot application. Servlet container is required for GeoServer. I will give some details on it on the next slide. And finally, as a front end, we will use a simple HTML page which will send REST requests to our web application, and also receive raster images with geospatial data from GeoServer using WMS and WFS protocols. Let's talk a little bit about GeoServer. It is a Java-based server that allows to view and edit geospatial data. It is driven by Open Geospatial Consortium and has such useful features like displaying data using Web Map Service protocol. It is a protocol that allows to share geo-referenced images over the web. Also styled maps and editing using web feature service. This protocol shares geographic markup language data over the web. It is useful for creating systems with interaction to the data. For example, you can retrieve some spatial data set, edit it, edit some attributes, and update it using the same protocol. Also, it supports map tiling and is extendable with plugins. Okay, so now I will show you a workshop on how to create a simple JS web application. So let's start with GeoServer. Here you see Tomcat running, and inside it we have GeoServer. Let's log in. So here you can see already some sample data is available. If you need to collaborate and check your system to work with GeoServer. So let's create a data store for our application. will be on localhost. We'll set our database. Schema is GIS. And, user and password. There are also connection parameters. Can adjust them. So it created a data source and now it see that we have a coastline table there, and it proposes us to create a layer from it. So let's publish this layer. Here are some basic parameters. We will need to provide bounding boxes for our layer. We can compute them from our data just in one click. And also there publishing, caching security attributes. You can add styling for your layer and so on. But we will just need a simple WMS layer. Okay, so let's save it, and now let's move to our web application. So here is our web application. It is a Spring Boot application where we will need some certain dependencies. We will need Java Persistence API. Also, we will need Hibernate spatial extension. And also, as I already mentioned, GeoTools models for manipulating with spatial data. And also the GTS core is also required. Then let's have a look at our properties. Here are the data source properties, driver, host, database, credentials, and also one important property. We need a PostGIS dialect in our application. So let's take a look at our entity that refers our coastline table. Here's identifier driven by a sequence in PostgreSQL database. Then we have parameters for the coastline, and finally the geometry column, which will contain spatial data. If you don't like this boilerplate getters, etc., you can also add a Lombok as a dependency and don't create all this stuff. Then we will have a simple coastline service that will retrieve and save coastlines to the database. We'll implement a simple repository. So now more interesting part, it's our REST controller. We'll have a method for retrieving coastline from database. Also, we will have a method to take only well-known text data by coastline ID. We will have a post method to save a new geometry provided in well-known text format, and also we will add a method to create a circle by longitude and latitude coordinates and a radius. Let's compile and start our application to see some examples. Let's clean and install project, and then we will run our application. So application is running, and let's see what we have there. I added a Swagger to Spring Boot application for easier representation of REST methods. So here we can see our REST controller, and let's take a look at our get method. For example, let's see what we have in coastline with ID 777. We can see that we have some problems here. We received the attributes, but there are problems with describing the geometry in JSON from binaries. So let's have a look at representation that will give us more readable geometry representation. And here we can see the well-known text. This well-known text was decoded using well-known text writer from GeoTools library. We retrieved the coastline and then fed its geometry to our well-known text writer and returned the result. And now let's go back to GIS server and let's see what we have in our layer. GIS server provides a convenient preview for layers using JavaScript library OpenLayers. So here we can see our coastlines, and this also can be added to any view, not only can be visible from GIS server, like you can use this sample to create your own page and provide the visualizing of your layer using WMS protocol. So let's add some data to our example. So let's imagine that we have some new coastline here between Africa and Australia. Let's go to our Swagger. Here we have a method save from well-known text. Let's try it out. For example, let's add such geometry. And see. Here you can see that the new geometry appeared in our map. And also let's have a look at one more method that will create a circle from a point. Okay, let's use the same coordinates near our new coastline. And let it the radius be 15 units. And here you can see that such a beautiful island is created. So now let's have a look at this method. Methods for saving geometry. We used the well-known text reader that decoded our text representation, converted it to geometry, and saved the new coastline using coastline service. And when we were creating a circle, there is a more sophisticated example. As we can see from our coastline database, the geometry type is multi-line string. And we need to keep the geometries only of this certain type. But our geometry builder that creates a circle, it stores this circle as a polygon. So here we use Geometry Factory to extract the exterior ring, this like boundary of our circle. And we create a new multi-line string and then pack it to our coastline and save to the database. So this was kind of a very simple web application, but I hope it was interesting for you, and this is a very big topic. There are numerous of formats and use cases for GIS applications. So maybe we'll meet at another meetings in other conferences. So I hope we had a good time, and you can ask your questions in Slack channel. So I will try to answer them. So have a nice day. Goodbye.